Hi, in today's class, we are going to add and subtract radicals. Addition and subtraction of radicals. So what is a radical? A radical is any number in the square root sign. When you have numbers in square roots, we call them radicals. For example, you can have something like root 5. Root 5 is a radical. Yes, you can also have something like maybe root 3. Root 3 is another example of a radical. So when numbers are in square root sign, they are called radicals. So today we are going to be adding and subtracting radicals. So radicals are part of the math that we solve. So I can see that to do radicals, you need to actually know some steps. You need to know some steps. The most important thing that I always advise students to do when solving radicals is first check if the radicals are in their basic forms. That's they are in their lowest form. Some radicals cannot be broken down into smaller values, while other radicals can be broken down. So you need to know the nature of the radical first. What do I mean by that? For instance, you have a radical like this, root 20. This radical is not in its simplest form. So when they say you should add root 20 to something else, you can't just add this root 20. You need to first break down this root 20 to its simplest form. And there's a logic. That's what you need to know here. In breaking radicals down to their lowest form, we look for perfect squares. We look for factors of the number that are perfect square. For instance, look at 20. 20 has so many factors. 2 is a factor of 20. 10 is a factor of 20. 4 factor of 20. 1 is also a factor of 20. 5 is a factor of 20. So out of these factors, which of them is a perfect square? What is a perfect square? A perfect square is a number you get when you multiply another number by itself. For instance, 4 is a perfect square. You get it when you multiply 2 by itself. 2 times 2, 4. 9 is a perfect square. You get it by multiplying 3 by 3. 3 times 3 is 9. So we are looking for a perfect square here to help us to save the situation. Because if you can't find the perfect square, you won't be able to break down this radical. Okay, so we're going to break down this radical 20 to bring out the perfect square. So 20 can be written as root 4 times root 5. Check it out. And the aim is to bring out the perfect square there so that we can take the square root. Remember, you can easily take the square root of perfect squares. You can easily take the square root of perfect squares. Yes. Root 4 multiplied by root 5. So what is the square root of 4? Square root of 4 is 2. So this is 2 times root 5, and that's 2 root 5. So we have now reduced this root 20 to its simplest form, which is 2 root 5. So when you reduce radicals to their lowest forms, they can now be added or subtracted. But again, I want you to know something. I want you to understand that you can't just add radicals. You add or subtract similar radicals. That's the golden rule. The golden rule for addition and subtraction of radicals is that you only add or subtract radicals that are similar. Similar in the sense that if you have root 5 plus 3 root 5, you can add these two because the numbers in the square root are 5, especially when they're in their basic form, in their lowest forms. You can add them. This is like 1 root 5 plus 3 root 5. That's going to give you 4 root 5, because 1 root 5 plus 3 root 5 will give you 4 root 5, because the root 5s are 4. But in a situation where you have root 3 plus root 7, it's not possible to add these two because the numbers are not the same, the radicals are different. You can't add root 2 plus root 7. It's not possible. You're not going to get any reasonable. It's not possible to add them. It's not possible. So what do we do when we have this type of question? There's just nothing we can do. Remember, radicals could just be seen like variables. Let's assume that root 3 is x and root 7 is another radical, which is like another variable like y. So x plus y, there's just nothing you can't add x to y because they are not like terms. So radicals can also be like, they can be similar. So you can't add radicals that are not similar. You only add radicals that are similar, and you only subtract radicals that are similar. So that's the point. So we have two steps, as I said before. Step 1, reduce the radicals to their simplest form. That's always the first step. So always the first step, you do what? Reduce radicals to their simplest form. Reduce them. Reduce radicals. Reduce the radicals to their simplest forms. That's the only thing that works for you. Then step 2, what do we do in step 2? We add or subtract similar radicals. You only add or you subtract similar radicals, because if they are different, you can't add them, you can't subtract them. So the rule says you only add or subtract like radicals. You can see call that, you can see call it right, the like radicals or similar radicals. So you add or you subtract like means similar, okay, like radicals. This is how this thing works. Once you follow these two rules, you are good to go. You can solve as many questions as you want. So that's it. So I want us to solve this first question here, this first example. But let me scroll down a bit. The first example says 2 root 5 plus, it's an exercise actually, 2 root 5 plus 4 root 5. That's the question. That's the question. 2 root 5 plus 4 root 5. Plus 4 root 5. Now the first step is we need to check, are these radicals in their lowest form? Yes, I can see there's just no number inside the bracket that can be broken down, so we don't have to reduce this one. Now step 2, are the radicals right? Like, are they the same, similar, like radicals? They are similar because the number inside the square root is 5. So we have 2 root 5 plus 4 root 5. It's like saying you have 2x plus 4x. So 2x plus 4x is 6x. So 2 root 5 plus 4 root 5 is going to give you 6 root 5. So for the first exercise question, the final answer is 6 root 5. That's it. So question 1 is solved. Look at question 2. Look at question 2. Question 2 says simplify 2 root 27 plus 3 root 3. We're solving that one too. This is question 1 here. This is question 1. So let's see question 2. Question 2 says what? Let's check that again. 2 root 27 plus 3 root 3. 2 root 27 2. This is question 2 now. Question 2 says 2 root 27. 2 root 27. Please, this is 7. 2 root 27 plus 3 root 3. So the first step is let's check if we're going to reduce any radical to its simplest form. Let's check if we're going to reduce any radical to its simplest form. I can say 2 root 27. 27 is a big number, and as I look at it, I know there's a perfect square that is a factor of 27, and the perfect square is 9. So I'm going to break this 27 down. So I'm going to have 2 root. If we break 27 down, you're going to get root 9 times root 3, because 9 times 3 is 27. So we've broken root 27 down, plus, remember, there's a 3 root 3 there. Okay, so let's move further. Let's move further. So we have 2 root 9 times root 3. It means you can break this root 9 times root 3. Okay, that's the next step. So this is 2 times root 9 2 times root 9 times root 3. This is how this thing is done. Root 9 times root 3 plus 3 root 3. So the next thing is, let's take the square root of this perfect square 9. The square root of 9 is 3, so that's 2 times 3, so that's 6. So we'll have 6 root 3 here. 6 root 3 plus 3 root 3. Remember, the numbers inside the square root, are they similar? Yes, they are similar. So once the numbers are similar, we can add them or subtract them. So 6 root 3 plus plus 3 root 3, not just plus root 3, but plus 3 root 3. 6 root 3 plus 3 root 3, it's like you're saying 6x plus 3x. And we know that 6x plus 3x is 9x. So 6 root 3 plus 3 root 3 is 9 root 3. So that's how this radical addition and subtraction is done. This works same for addition and for subtraction. So you can run more of these exercises, like look at question 4, where you have 3 root 2 minus 3 root 18, and you can just first check if you can reduce any of the radicals to the lowest form, then check if you have similar radicals, then you can either add them or subtract them if they are similar to get your final answer. So I believe from this explanation you should be able to add and subtract radicals without much stress. So that's where this explanation, this class is going to end, this lesson is going to end. We're going to see again in another video where I will be taking on multiplication of radicals. Thank you.